Okay, here is the review from the book for Chapter 6. So I'm going to go through page 407, 1 through 15, and then page 797, 11, and 12 right after that. And we'll start right here. And it says, which of the following could be evaluated to compute the mean of this probability distribution? Now, we know we can plug this right in our calculator, but the actual formula says I take 0.1 times not 0.1. I take 1 times 0.20, and then 2 times 0.35, 3 times 0.15, and so on and so forth. That answer in your book is letter C. For the second one, it goes ahead and says each half of a college basketball game is made up into these 2 20 minutes of playing time, but the real time elapsed is listed right here. Okay, so it asks what's the mean real time for the entire game. That's pretty simple. You just do the mean of the first half plus the mean of the second half. So the mean of the entire game, let's say the time of the entire game, is going to equal the first half plus the second half. Let's see if we can get this to actually right. Okay, so the mean time is just going to be the mean of the first half plus the mean of the second half. So that's just 48 plus 52, or that is 100. Okay, now the next question is asking about under what conditions would the standard deviation of the first half and the second half be equal to the square root of, well, remember, first half plus second half was equal to the time, correct? So the variance of the time should equal the variance of the first half plus the variance of the second half. Now the only time that this is true is if they are independent of each other. Okay, and that's the big word here. So that would mean the standard deviation would be the square root of these variances. And the variances would be 6 squared and 8 squared. So this is, in fact, this formula here, which does equal 10. That only happens when those two halves are independent. They have to be independent. Okay, 10% of the students at a particular school own a pet. Consider a chance experiment consists of selecting a random sample of 20 students. Once you see that, you should be thinking, okay, this is a fixed number of trials. Let X be the number of students in the sample who own a pet. So we've got N, we've got X, and we've got P. That's a probability. Random variable X, which has the following probability distribution. This is a binomial. Fixed number of trials. Trials are independent of each other. The fact that you have a pet wouldn't affect the fact that someone else has a pet. And then the probability that's the same for each trial, which is 0.1 or 10%. Which of the following histograms has the largest value of P? The largest value of P would be with the highest mean. So if I'm looking here, I'm just kind of guessing means. This mean would be around 2. This mean looks like it's over 9. It's somewhere probably up in the 9 to 9.5 range. This mean here is somewhere right in here in the what's that, 5 or 6 range. I can't quite see that very well. And then this mean here is probably somewhere right in this area or just above. So the greatest mean is going to be A. All right, so if the number of accidents in any 2 months are independent, what's the probability that no car accidents occur at this intersection for 2 consecutive months? So it's a probability of 0 for the first month and 0 for the second month. Okay, this is actually back to last chapter. So it's the probability of 0 times the probability of 0. All right. No car accident. Yeah. So it's 0.11 times 0.11, which is 0.0121. Okay. Number 7, a normal probability plot suggests that a normal probability model is plausible when we have a strong linear pattern. So a substantial linear pattern is present in the plot. Then that means that our data comes from a normal distribution, or we assume it comes from a normal distribution. Normally distributed population mean 0 and standard deviation 1. The population interquartile range is close to which of the values? Okay, this one's a little bit more complicated. So the population interquartile range would be the middle 50% of the values. Okay? Now I don't know what these z-scores are, but they should be symmetric. One should be positive and one should be negative. All right? I do know if 50% of the data is in the center of my distribution, then I have 25% outside on each side. Okay? If I have those 25%, if I want to calculate this z-score here, the z-score can be calculated by finding the area under the curve that is 25%. So if that area is 25%, that's going to give me the z-score. So this is where I'm going to use the inverse normal in my calculator. So I'm going to bring this up. I'm going to do distribution inverse normal. Remember, inverse normal, when I give it an area, it gives me the z-score from that area. Okay, so there's my area, 0.25. If I paste that in, it should give me a negative z-score. So negative 0.6745. Let's call that negative 0.6745. And this one will be positive 0.6745. So the interquartile range is just the bigger number minus the smaller number. So this is going to be let's see if this computer wants to work, 0.6745 minus a negative 0.6745. And when I put those two together, I get, I think, about 1.349-ish. Okay? That's where we got that from. Which of the following is not a property of a binomial? It does have a fixed number of trials. Outcomes are independent. Each trial can result in one of, no, each trial can represent in only one of two outcomes, success or failure. So that's where it goes. Probability of success is constant. Observations consist of a number of successes for each trial and experiment. That's correct. So number 9 is C. Number 10. Okay, so the probability that any individual passenger checks luggage is 0.3. What's the probability that exactly 40 out of 100, fixed number of trials, n, probability of success is the same for each trial, and they're asking for an x value. This is another binomial. And I know it says binomial random variable, but it didn't need to say that in order for us to be able to answer this. Now they're using the binomial formula here. Now the binomial formula is n choose x times p to the x and 1 minus p to the n minus x. Now this is on your formula sheet, but that's the binomial formula. So that's why it is E. I don't think you'll get something like this on your test. You might have to calculate this probability, but I don't think you have to write it out as the binomial formula. I know I've never seen that on the AP exam where you had to write that out. Okay, 100 students are selected at random with a mean and standard deviation of random variable x. So again, this is binomial, fixed number of trials, success or failure. You either have to it or you don't. Let's assume they're independent. So the mean of the binomial is n times p, and the standard deviation is the square root of n times p times 1 minus p. So the mean is just 100 times 0.65, which is 65, and then the standard deviation is the square root of 100 times 0.65 times 0.35. I'm not sure what that is, so I'm going to use my calculator. Square root of 100 times 0.65 times 0.35. And I get 4.769, 4.77, something like that. It's E. Okay? Number 13, suppose that x is a random variable. It has uniform distribution. Uniform distribution means, like say that's 10 here, it goes from 0 to 10, means that's the same height across. And if I want to know the height, it's equal to 1 over the width. The width here being 10, So the height of my interval is going to be 1 over 10, because 1 over 10 times 10 is 1, right? So it says, which of the following probabilities is the largest? Well, let's think about this. 2, 1, 7, 8, 9. Okay. Let's think about this. If I'm doing the probability that x is greater than 8, or even x is greater than or equal to 8, those two values should be the same. That's these two areas right here. Okay? Well, that area is just 2 times 1/10, the width of the interval times the height of the interval, which is 1/5. So both of these probabilities are identical at 1/5. And I'm assuming if they're identical, that they're not going to be an answer. This probability right here, that x is equal to 10, is in fact 0. Okay? Between 3, which is right here, and 6, which is right here, I have a width of 3. So that's 3/10. That's a little bit bigger. And then x is less than 4. That's from here down. That's actually going to be my biggest interval. It's 4/10, or 2/5. So E is my answer. Okay? But remember, uniform distribution means it's the same height all the way across, and you calculate the height of that by doing 1 over the width. Okay, what's the probability that exactly what's the probability that exactly 3 boxes must be purchased? Okay. So you're going to buy until you find a prize. So it means on the first 2 you won't find a prize, and on the third one you will. So this is geometric. First 2 are failures, and the third one's a success. Don't make the mistake of putting B here. That's addition. We don't do addition there. All right. Last one. For a normal distribution with a mean 100 and a standard deviation of 10, find the 95th percentile. Okay. So again, when it asks us what the percentile is, we use inverse normal. So that means 95% of the data is at or below this. So it's somewhere in this range here. Okay. So I need to find what that z value is right there. And that's how I use inverse normal. Inverse normal, we plug in an area. In this case, it's 0.95. And it gives us our z-score, which in this case is 1.645. So z is equal to 1.645. So now we work out our equation. Z is equal to x minus mu over sigma. So 1.645 is equal to x minus the mean, which is 100, over the standard deviation, which is 10, which makes that calculation really easy. Multiply by 10, add 100. Answer is E. Okay? All right, so that magically fixed itself. Now let's hop on to the free response questions. Now these are on page 797. Again, pause if you need to pause. All right, the first one is it's kind of funny when you're reading about the rump of a horse. Yeah, I'm not going to get into all that. Basically, they place 2 horses next to each other and hitch them to a chariot. I'm sure you've seen this before. For the chariot hitching purposes, the widest measurement across the horse occurs in the rump area at their backsides. Suppose that the mean rump area of the width of horses is 27 inches. So I'm going to say mu sub r for the rump area is 27 inches, and sigma sub r is 2 inches. Okay. Let the random variable w be the so I guess I should change that from r to w, because I guess they're saying rump width. So there we go. The usual length measured as it applies to a horse is the hand. And this hand is a definition equal to 4 inches. So a hand is 4 inches. So to find the random variable h in where it is equal to width in hands across the rump. Whew, that's interesting, isn't it? So let's think about this. So h is going to be 1/4 times w. And let's think of why that is. a hand is 4 inches, okay? If W is 27 inches, I have to divide that by 4 to figure out the number of hands I get. And that's why I'm going to have to multiply it by 1/4, okay? So it means it's 4 times as big as W. So it's still just a linear function here, all right? So it says, what are the mean and standard deviation of H? So the mean of H is 1/4 times the mean of W. And that's pretty simple. The standard deviation of H is 1/4 times the standard deviation of W. And again, it's because it's a linear function. So this is 1/4 times 27. And this is 1/4 times 2. So this looks like 6.75, and this looks like 0.5. So that's the mean and standard deviation for the number of hands, the width in hands across the horse. All right, so let's say, suppose horses are randomly chosen from a particular Roman chariot. Define the random variable B to be the total rump width in inches of 2 randomly selected horses. So now we're back to the width, and B is the total rump width of 2 randomly selected horses. So B is equal to W plus W. These 2 horses are different. They need to be separated. They're independent of each other. Okay, they're randomly selected. So the mean of B is just the mean of W plus the mean of W. Okay, so this is 27 plus 27, or it's 54 inches. Okay. I guess I should completely say this so it looks complete. Okay. Now, the standard deviation of B has to be calculated by using the variance first. So it's the variance of W plus the variance of W. Again, these because they're a linear combination, 2 independent horses. Okay. So the variance of B is equal to 2 squared plus 2 squared. So that means the variance of B is 8, making the standard deviation B the square root of 8. I think I should know what that is, but I don't remember. The square root of 8, 2.828. Okay. So that takes care of Part A and Part B. Part C says, in the original chariot design, a 16-inch separation of the horses is specified so that the horses have room to avoid each other. Let's divide a random variable of chariot width, C, this is Part C, and that's equal to 16 plus W1 plus W2. Or you could just say W plus W. It's the same thing. I mean, I could put the 1 and 2 up on B. It doesn't matter. How do the mean and standard deviation of Part D differ from the mean and standard deviation of the random variable Part C? You should be able to answer without calculating. Okay, so let's not do any calculations. Let's just think about this. The mean of C should be, or is, 16 inches larger than the mean of B. But the standard deviation of B should be the same. Okay? And the reason they should be the same is this constant. When we add a constant, it doesn't affect our standard deviation at all. Again, think of our numbers. Let's say I did something real simple like 1, 2, 3, and 4. And I added 10 to each of them, made it 11, 12, 13, and 14. So each one of these had 10 added to them. The mean has now jumped from 2.5 to, what's that, 12.5. It's jumped by 10. But the amount of variability has not changed at all. These numbers aren't any more spread out than these numbers. Their standard deviations would in fact be the same. Well, that's what's happening here. The mean jumps by 16, but the standard deviation stays put. On to the last one. Okay, it's another very interesting because this is about burgers and onions, and are the onions going to fit on our burgers or whatever. So basically, they're looking for onion suppliers, and they've determined that they found 2 of them. Okay, Company A's onions. So the mean of Company A's onions is 10.5 centimeters with a standard deviation of 1.1 centimeters. Okay, and again, they're approximately normal in their distribution. So I know I'm going to use z-scores here. Company B's onions are also normally distributed, or approximately normally distributed, and the mean of B's onions is 10.3, and the standard deviation of B's onions is 0.8. And they only select onions. They're only allowed to have onions that are between 9 and 10 centimeters. Apparently, anything bigger than that, it won't fit on their burger. So it says which company, and I laughed when I read this, which company has a higher proportion of burger usable onions, whatever. So basically, we're going to calculate the proportion of A, that would be between 9 and 10, and the proportion of B, that would be between 9 and 10, using z-scores. So we're going to start with the probability that A is between 9 and 10. So 9 is less than A, which is less than 10, right? And that's just done really easily through a z-score, okay? All right, so this is the probability that 9 minus the mean, 10.5, over the standard deviation, 1.1, is less than z, which is less than 10, minus the mean over the standard deviation. Okay? And I plug that into my calculator, and I get negative 1.364 is less than z, which is less than negative 0.4545. Okay? And this probability I'm going to plug into my calculator. All right, so wrong button there. Well, don't read my emails, so let me put that back. All right, let's try the calculator this time. Maybe. There we go. All right. All right, normal CDF. My lower boundary is negative 1.364. My upper boundary is negative 0.4545. Mean, standard deviation, put it all together. I get about 0.238, let's just say 0.2385. So that means about 23.85% of burger, or I guess, I'm sorry, of Company A's onions are burger usable. Okay? So that took care of Company A. Now we have to do the same thing for Company B, but it's a simple calculation. So now we're trying to calculate the probability that 9 is less than B, which is less than 10, which is the probability that 9 minus, and now our mean is 10.3, over our standard deviation of 0.8 is less than Z, which is less than 10 minus 10.3 divided by 0.8. So this is the probability that Z is between negative 1.625 and negative 0.375. And I think we can see that this is a little bit wider here than this, so we should have a little bit greater probability. It's covering a little bit more area underneath that curve. And in fact, we do get a greater probability. I'm not going to plug this into the calculator. I think you guys can do that on your own. But I got about 0.30175. We could call that 0.0 or 0.302, whatever you want to say. So it looks like about 30.2% of company B's onions are burger usable. Okay, so it told us which company provides a higher proportion. Company B. Answer the question. Make sure they answer the question. A higher proportion of burger usable onions. Kind of a really weird question, but hey, 30% is higher than 23%. That's why we would say they have a higher proportion. Hopefully this helped. There's this video along with the other one. Should give you some good insight for your test.